Now I'd like to invite Dr. Mohammad Abdel-Majeed, the Vice Chair of the Computer Society chapter in Jordan, to introduce our distinguished visitor. Please, Dr. Mohammad. If you would like to say
Hello, everyone. As I mentioned, my name is Mohammad Abdel-Majeed, and I would like to welcome and thank you for joining us today for one of our events, in which we have our distinguished guest, Professor Kostas, who's joining us today as part of the Distinguished Visitor Program, IEEE Distinguished Visitor Program. Dr. Kostas is an assistant professor at Panettion, is it correct? University of Social and Political Sciences. He was the former research director at the National Technical University of Athens. He is a member of IEEE Explainable AI Working Group, and also he has an extensive experience in research projects funded by Greece and the European Union. Today he will tell us more about AI and machine learning for games, the field in which he has long experience. For example, he has notable contributions in emotion modeling and recognition. He is the chief editor for Frontiers in CS Human Media Interaction section. He co-edited a book on emotions in games, theory and practice. And also he is a speaker at TEDx. He was a speaker at TEDx events, in one of them, he authored a lesson with the title, Can Machines Read Your Emotions? With this brief introduction to our guest, I'd like to welcome him to tell us more about AI, machine learning for games. Please, Dr. Kostas.
Thank you very much for the introduction. Thank you very much, Professor, for the invitation and the hospitality. I have to say that I've visited quite a few sections over these past 2 years, given my position in the Distinguished Visitor Program. And I've never seen so many motivated volunteers, both in the senior level and in the student level. And I congratulate you for this. I'm sure it's been an effort that has been lasting for quite a few years. It's not just now. And of course, it's very nice to see that you're recognized in Region 8 and worldwide by IEEE. So what I'm going to discuss today is actually how relevant games are in terms of collecting information and data from users. This information doesn't necessarily have to do with the way they play or their devices or their behavior. For instance, it can also be used in for other uses, such as commercial behavior, buying behavior, and maybe to improve the network conditions in one particular spot and so on. For the second part of my presentation, I'm going to discuss how we can adapt games using this information in order to either make a more meaningful player experience for our players, or given that games are notably expensive to produce, earn some money from them. Okay, this is something that we don't like to discuss because sometimes it seems unethical. But at the end of the day, we must remember that games actually combine the difficulties from two different creative industries. One of them is, of course, software engineering and design and development, because games are meant to be played in mobile devices, PCs, consoles, and so on. So hardware is very relevant also for that. But on top of this, we have to make sure that we understand that games are also narrative works, like TV series, like movies, like books, like theater plays. So they combine the intricacies from both these worlds, and sometimes they combine also the costs of both these worlds. In the morning, I had a similar discussion about this, and one of the students told me that he thinks that game development is very competitive and very demanding in terms of knowledge. My experience and my understanding is that, maybe I shouldn't say it, but since we're in the company of good friends, I will say it. It's not rocket science. Okay, it's not very difficult. It's not, I don't know, algorithm design. It's not machine learning or artificial intelligence design. In terms of algorithms, it's quite straightforward to build a game. But on the other hand, given, as I said before, that we should also consider the fact that games are narrative works, this doesn't necessarily mean that it's easy to design a good game. And I think you know that from your own experience, from the games that you played. Some of them are impressive when you download them, but they're very boring when you start interacting with them. So as was mentioned before, most of my experience in the field comes from a number of European Union-funded projects in which we developed a number of games. In both these games that you see here, on the bottom side, you can see Siren. The other is called Navigo. Siren was about conflict resolution learning in primary schools, so it was targeted towards 10 to 14-year-olds. And the other was about introductory language learning. In the first case, we employed AI in order to build quests, so sets of objectives for the young students, for the players, to try to fulfill within the game. And these quests were designed in such a manner so that they were not very demanding, they were not very stressful, and this was actually a requirement posed to us by the teachers themselves. But at the same time, they were also hard enough to be interesting. And in the case of Navigo, AI was used to select and generate proper content for each student based on their proficiency with respect to different parts of the language that they were supposed to learn. So when I was a student, the handbook that we used for AI was this thick. It was very, very small. We had, as a professor, one of the most prominent researchers in Greece, who was thankfully still around. And most of the content of the course had to do with a strange programming language called Prolog, programming in logic. So what we did, and we called it AI, was try to come up with sort of rules that made sense, hence the word logic. For instance, if A is B and B is C, then A is C. Okay, that was not very exciting, but that was what was considered AI at that moment. So these days, these are all concepts related to AI. Don't worry at all. I know it's not readable, so I've cut it into 3 pieces in the next slides. I just added the full form to include the link in the description. This is actually a map of how AI is used in video games. It's produced by a former professor of AI in games who quit his job in academia. He works in Scotland. His name is Tommy Thompson. So he quit his job in academia to become a science communicator. So he started a channel called AI in Games, of course. This is the logo at the bottom. And he actually discusses in the videos that he uploads on YouTube how AI is implemented, how different algorithms are implemented and put to use in commercial games. So if you want to actually grab an idea, get an idea of how AI is implemented in a commercial game, I suggest you follow his channel. So what Thompson suggests is that we can use the same definitions and the same divisions of the field of AI. So there's that diagram that you see on the right. You usually see it in the form of a Venn diagram, the one with the circles, about machine learning, which includes deep learning and these days generative AI, and so on, to try to combine elements from player behavior, elements from how the game is run in terms of performance, and of course, the actual characteristics of the game, in order to drive or generate different parts of the game. So the NPCs are the characters who are not controlled by the player, non-player characters. Sometimes we call them bots. They may be our enemies, or in a role-playing game, they just wander around the game world and so on. Of course, controlling the opponents is very interesting. I will talk about procedural generation in the second part of my talk, after I discuss what constitutes content. Another very important issue in modern games has to do with online matchmaking. So given that most of the games that we play, especially on mobile devices, are multiplayer, it's very important to match two players with roughly equal skill. So that's not very easy to do. Okay, it's not very easy to measure the skill of one player in such a manner that you can use it in this context. Another very hard problem in the same framework has to do, for instance, with chess. So I'm sure you know that for a long time now, computers can beat human players in chess. So it's relatively easy, quote unquote, to build a perfect player to play chess or backgammon or Go and so on. But me as a player, as a chess player who is not very proficient, I don't want to play against the grandmaster. I don't want to play against a machine that beats Magnus Eriksson, who is the world champion in chess. I want to play against an opponent against which I can last for, I don't know, 15, 20 moves, 25. Maybe I have a chance of winning. So the difficult part in this case has to do with creating an AI that's not perfect, that makes mistakes and makes mistakes in a measurable manner. So in chess, we have a numerical representation of skill called ELO. So each player has an ELO rating. So the idea would be that we want to create an AI that plays as an ELO 1500, a different AI that plays as an ELO 2000, and so on. So I can select the skill of my computer opponent. And after creating the game, as I said earlier, games are very expensive, not only to create, but also to run, because you have to go back. Again, I will say that they are software products. So inevitably, there will be bugs to fix. There will be servers to maintain. There will be communities to maintain, communities of players, and so on. So we still have costs that we need to tackle. They are also bringing out the best and the worst in people in terms of expressing our emotions or communicating with each other. You may see it when you're in a state of flow, you play the game for 2 hours, you're very close to winning, but then you lose, and then your parent comes to you and asks you something irrelevant. Then you're immediately very angry and you lash out on them. Of course, this is not something that you would do every day. And this is an effect, a direct effect of being involved, being in a state of flow within the game. So we want to detect not only that, but also the parts related to toxicity. So in many cases, because players can communicate either via text or through voice chat or through online communities and so on, there have been cases of bullying, there have been cases of textual or messages related to violence and threats and so on. And because these are related to the game itself, of course, they are the responsibility of the persons who communicate this way. But when the news go out in the TV or on the internet, they will say that, I don't know, GTA players use this and this language to threaten each other and so on. So many major companies actually utilize AI to try to monitor and check the ways that players communicate with each other, either within the game or through the online communities. And finally, one major part that may be relevant to you as future developers or engineers has to do with quality assurance. So again, games have a dual nature. They are software products, so they need to be tested. But because there are many levels and many things to test and check and so on, it's not that we only want to eliminate bugs that make the software crash. Okay, we also want to check the game, to test the game with respect to the narrative parts. I will discuss this in the following. But AI is currently used. Again, Tommy Thompson is working closely with a company called Model AI, which is based in Malta and in Sweden. And what they're doing is offering services to game companies to test their games using AI players. So instead of hiring, I don't know, 10, 20, 100 human players to play the game, they simulate those human players and they get 10,000 results in the same duration, in the same time. So this is also a part where AI can be combined with games. Some concepts related to player modeling, because this is very relevant to collecting information and then using this information to adapt the player experience. The first part has to do with adjusting or enforcing what we call dynamic difficulty adjustment. The relevant algorithms are called DDA. So we want our game to not be very easy because it's going to be very boring for our players. And of course, we want our game to be not so hard because in the end, they're going to give up and play a different game. And this is important not only because in some cases, players pay the money and they want to be happy about their purchase and so on. Think of the competition that games have on Play Store, on App Store, on Steam, where you can download games from. Every day you get literally hundreds of new games. So the first challenge for a game development company has to do with convincing us to download a game. And then the second challenge would be to convince us to keep playing the game and not stop, uninstall it, or do something else with it. The second part of why player modeling is relevant has to do, of course, with making money from it. Most games, again, are free to play, free to download. You can play for years and not spend a single dollar or a single euro or a single JD. But of course, companies cannot live this way. Okay? They have to earn their money from some point. They used advertisements for a long time, but they're not very effective because, of course, let's face it, when you are in the middle of the action, you're not really interested in watching the same advertisement of a food delivery company, something irrelevant to the game again and again. Okay. And another important issue has to do with the number of players you need to have in order to get a meaningful amount of money from your advertisements. You need to have more than 100,000 players at any given time in order to make money from ads. So what we do is ask for real money from our players in exchange for virtual currency. And then players can use that virtual currency. Maybe it's gems, it's diamonds, it's gold coins, it's, I don't know, mana, if you're a magician, a mage, or something like that. And you can use this virtual currency to buy new weapons, to buy new content, for instance, new levels for your game, or even to buy things that are not relevant to the action. They're not going to make you a better player, but they are what we call cosmetic improvements. So for instance, Fortnite is famous for this. You can play Fortnite again and not pay a single dollar, but you can get, I don't know, different skins and different objects related to Darth Vader when there's a promotion about Star Wars, or different singers, or I don't know, LeBron James, or I don't know who else. So for me, it's very hard to believe that people pay money to get the sunglasses worn by a famous singer, but who am I to judge? Okay. Yes, that's probably the case. So we need to find information to make us actually understand our players better. So the first source of information has to do with the device that the game is played on. So 15 or 20 years ago, things were different. Things were simpler because there was only a single iPhone make. So we knew its specification, its power, and so on. There were 3 or 4 or 5 different Android phones, PCs, and PlayStation, and that's it. And these days you have 10 or 12 different iPhones. You have Android phones starting from, I don't know, 80 or 100 euro all the way to almost 2,000. You have different versions, backward compatible consoles and so on. And of course, you have computers starting from, I don't know, 300 or 400 euros or dollars all the way to gaming PCs of a few thousand So what we want to do is try to note, try to record, and then utilize in the context of an AI algorithm how the game performs as a software program, how fast it runs, whether there is a lag, there is a delay in the network condition for our players. It's very important, given, as I said earlier, that most of the games that we play these days are multiplayer. It's very important to have an equal experience, an equal presence for all players. We don't want someone to lag behind 1 second, because of course, in that 1 second, they may miss something, they may be killed in the game, and so on. So the more data that we collect with respect to the performance of the game as a software product, the more opportunities we have to fine-tune its performance for the next update. With respect to individual players, we can monitor the choices that they make within the game, the keystrokes that they use, the different key presses in their console controller, and so on, and the parts of the level that they visit or that they don't visit. And this is actually information that we can use in the context of the design team in order to make our levels better and more playable. As I said, we don't want our levels to be very hard. So if we track the player's route, the player's itinerary within the level, and we find that they keep losing at one particular point of the level, then we have to go back to the drawing board and redesign that particular level in order for them to have chances of progressing. And finally, the in-app purchases, the buying or consumer information. This has to do mostly with the points, the parts of the game where it's more probable for our players to spend money, to spend real money to get our virtual currency. It would make sense to think, and that would be correct, that these points have to do with either the parts of the game where they lose, so they want to spend money to get more lives, to get more time to finish a level, and so on. But it also may be relevant to them stopping the game for a while, for 2 or 3 months, and then coming back to the game. So it's a very nice opportunity for us to then present them with an offer, quote unquote, again, to give them, I don't know, the new character or the new weapons or the new levels for $3 or $4 or $5, and so on. Another part related to the data, which comes from consumer behavior, has to do with the time of day, the state of the players, whether they are on the move or at home or at school, and of course the time of year. Especially the time of year is very important, because you may see, if you look again into Reddit or other sources of information such as Twitter, that many game companies would release their games just before the summer break, which makes sense because most of the players or some of the players are students and they have more time to play during summer. Another important cutoff date has to do with Thanksgiving in the United States, which is usually related to a shopping spree, Black Monday, Cyber Tuesday, Black Friday and Cyber Monday. Okay, I got it right. And so on. And these are important timing decisions that a game company has to make. Okay, so it's very important for them to release new content, but also to present their existing players with enough buying offers for them to lure them to spend their money. I mentioned community metrics. Usually the source that we go to get information and insight about how players think about the game is Reddit. So Reddit is what we would call a mega forum. There are different sub-forums or subreddits, as they call them, about anything. So what major companies do is go online to Reddit and start a dedicated subreddit there. So what's nice about this about these communities is that players would go online to discuss their game, to discuss strategies, and also inform, so to speak, the company about their complaints. And game development companies usually hire dedicated people, they call them community managers, to monitor these communities on Reddit and on Twitter. And of course, then adapt the game with respect to what players want. Another idea has to do with what we call social network analysis. This is actually a family of algorithms that originated, of course, from social networks. I think starting with Facebook and then moving on to Twitter mostly and Instagram these days. I'm mentioning these social media profiles because it used to be very easy to get data from them until Elon Musk. So what game development companies go there is try to identify which users who play those games are influential for other players. So if I say that there's a new release of this and that game, let's go buy it, and I get 25,000 likes in the space of 1 hour. And of course, this has an effect on the actual sales of the game. Then the game development company would come to me and ask me to play the game for 3 or 4 minutes and broadcast my experience on YouTube or on Twitch, which is a dedicated network, mostly targeted towards games. And this would be actually the most effective means of advertising new games. We don't have print magazines as we used to 20 years ago. Nobody watches YouTube ads. Okay, we always skip them. So the major means of promoting any new release would have to go through these influential users. And once we have the data, we can actually use it to adapt our game. In most cases, when we want to help users progress through the game, we do what's called spawning or generating new content, new objects. So this is an example of an object that you can pick up, and it replenishes your health in a first-person shooter game. The game was called Doom. It comes from a relatively old era of gaming from the 1990s. So the idea here would be that if you want to promote specific playing styles, for instance, you want to promote the style of going always into the fight instead of waiting somewhere and waiting for all your opponents to kill each other, as is usually the case with Fortnite, you would generate enough health packs for people to go into the fight, get some bullets, get wounded, replenish their health, and start from the beginning. It's not very safe because you always have, as a designer, some design ideas that you want to observe. Okay, so if my game is fast-paced, then it's okay to promote this specific playing style. But if I want my game to be, slower-paced and promote a more thinking style, I need to make sure that the content that I generate, the objects that I generate, actually fulfill my design in some respect. They promote specific playing styles that actually observe what I have designed. In terms of numerical values, in many cases, the different characters that we use in games correspond to different costs or different, as I said, numerical values related to damage, related to the health that they have, the damage they can create per second, and so on. So they give the players the chance, the freedom to adapt the player experience to their playing style. Someone wants a faster playing style, while others may opt for stronger units, which are more costly, but they make them more vulnerable in attacks. So what computer game design companies do is actually monitor the outcome of each game with respect to the units that were chosen and used by the players. So this is a screenshot from a very successful game called Clash Royale by Supercell, and it offers different cards and different units for players to use. So if Supercell detects that, for instance, someone who has the Musketeer on their deck has more than 70 or 80 or 90% chance of winning, then they're going to reduce its statistics. They're going to make the card, the hero, more vulnerable, less strong, so that it doesn't necessarily guarantee winning. So at the end of the day, they wouldn't want all their players to use specific cards. So winning or losing would come down to card selection and not skill. And this is what they do. They do that by monitoring, as I said, and recording all information related to card choices and how they are deployed within the game. Finally, I'm going to discuss an experiment that we ran a few years ago. we tried to combine the in-game behavior of players with their visual behavior. So the way that they move when they play games, how they move their head, whether they move their body left to right, and so on, and even their emotions on their face. And we wanted to do that because we wanted to see whether we can predict the level of interest given a particular stage or level in the game. So I'm going to use this experiment as a sort of a bridge for content generation. So the context of this experiment had to do with generating different Super Mario levels. So each player would play those two levels, and we would capture their performance in the game and on camera. And we would try to check different measurable indicators and see whether we could train a neural network with them. And at the end of the day, we reached a quite high level of performance. But sometimes you can also check visually these measurements. So this is a video of my colleague Eleni playing Super Mario. And the vertical axis has to do with the degree of motion. It's a very simple statistic which has to do with the pixels, the normalized pixels, in which the rectangle around the head moved with each frame. So we would see when we tried to correlate this with the actual keystrokes that Eleni used when playing the game, that whenever she used the space bar to jump, she would also go like this. And we will see that huge correlation, that strong correlation for players who reported that they were interested and engaged with the game. So it would make sense to go the other way around and see whether we could predict this. And as I said, we could, at the end of the day, predict their level of engagement. A funny thing had to do with another player from Denmark. We were working together with people from Portugal and Denmark at the time, who was like, if you've seen the movie Top Gun, he was like Iceman. He was like this. And he was always perfect at the game. It wasn't that he was not interested. He was so calm and collected. He was so in the game that he didn't need to move. So if we went the other way around and reasoned that because he was not moving along with his player, he was not interested, we would not be right. So this is why we had to bring in the level of performance for the game. We couldn't just rely on visual information about this. Moving on to the actual content generation. Usually when we speak about content generation in the framework of games, we think about visual elements. We think about the skins, the visual appearance, the clothes of our characters, maybe some aesthetic improvements, as I said. If it's an outdoor game, we may want to simulate winter versus summer and so on, okay? But usually we can actually adapt every part of the game, even the content that has to do with the behavior of the player. So, for instance, we can create new mechanisms, new weapons for our players, given their performance and given their progress in the game. Of course, music and other sounds are also very important in order to set the setting for the narrative part. And as I said earlier, we can create game elements such as the health packs that I mentioned earlier to correspond to what's happening in the game. So again, if we want to adapt the game to a specific part of the player experience, we can pretty much change anything, even the actual mechanics. These are two prominent examples of procedural content generation. The one on the left is, of course, Minecraft. Now, if someone wants to be a purist, we wouldn't call Minecraft a game, because there usually aren't any clear objectives or win condition or even narrative. But of course, if you talk to real people and you mention that Minecraft is not a game, they will think that you're crazy, but I just had to say it. So Minecraft is an open world game where you can create, given the resources that you have in the game world, you can create different structures, you can even create new elements and build things with them. You can build tools, you can build buildings and so on. So you can have sort of a virtual life, so to speak, in the Minecraft world. And the screenshot on the right-hand side comes from a game called No Man's Sky, which came out around 2015 or 16. So No Man's Sky was not as successful as we expected it to be, but this didn't have to do with the actual AI. So AI here is used to generate the next world that the player will be based on their actions on the particular world that they are currently playing. So no two players will face and will play and will exist in the same environment because they're not going to follow the same actions, which, as I said, are used to generate the content. So the advantages of generating content using code, which is the actual, I would say, definition of procedural content generation. One of the major advantages has to do, of course, with speed. If you want to generate 100 levels, you don't need to hire a level designer to do this over, I don't know, 3 months. You can run your content generated code 100 times with different parameters and then get the levels that you want. In real life, you would do that and then feed the actual result to the level designer for any omissions, errors, corrections, and so on. Another major advantage that PCG has to do with controllability. Since we are the ones who create the code to generate the content, we know that we observe the rules, we respect the rules of the game design, and the content that we create follows those rules, respecting the narrative. And of course, it's easy to create more content for our players because eventually our players are going to finish the levels that we give them. Even players who played, I don't know, the original Angry Birds games or Candy Crush Saga and its 576 levels, if I remember correctly, they will eventually finish. So if we want to keep them playing and keep them paying money for this, we can use PCG to generate new content, even with new aesthetics or new mechanics, as I said earlier. Now I'm going to discuss some introductory PCG algorithms, and I'm also going to point to some resources that you can use for them. So one of them is well known from the field of software engineering. It's called cellular automata, and it has to do with generating new content based on rules and based on initial conditions, in our case of the game map. So you can see here that you can start from a black pixel, for instance, maybe this one, from a set of 3 black pixels, and then generate automatically the 4th one. If you have a pattern of 3 white pixels, then the next will be a black, and so on. So you don't need to go and check each individual pixels in your 2D map. You can use this approach. This may seem simplistic. I will show you an actual example in the next slide. At this point, I would like to point you to this great book by Yorgos Giannakakis and Julia Togelius, the Game AI book. Even though this book is a commercial book published by Springer, you can still find on that website the PDFs of the first version. So it's a very nice introduction, either for aspiring game developers or even for a course that tries to combine game design and development and artificial intelligence. And at this website, you can also find some lecture notes and code examples that you can run. So it's a very useful resource, so to speak. So this is an actual example of a CA generation. It's called Biome. Biome is sort of an old-fashioned piece of software. It used to be around from the early days of Windows machines, and it can be used to create these kinds of patterns. So this could look like a forest seen from the top, or grass, and so on. And what is interesting, you can see at the top right of the screenshot that you can give it rules to start fires at some points, at random points actually, of the forest, which of course, they are fires for us. For the program, it's just orange and yellow pixels. And these fires will spread. So imagine having to do this by hand and having someone going click, click, click to generate the new version for its frame or for its generation or for its repetition. And you may see that it's actually sort of intelligent, because within the parts of the forest which have been burnt down, you can see new vegetation growing. So you can define rules to change the color of pixels over time. So besides the spreading of fire, you can use biome or CA actually as an algorithm to estimate the spreading, for instance, of diseases in a community. There's a very nice game called Plague. You can download it on your mobile phone, which simulates the spreading of a disease worldwide, and actually takes into account the different measures that states or countries may take in order to block this advance. Now, the suspicious thing is that Plague was available before the COVID pandemic. So, yeah, someone might think that, reality follows imagination or something like that. But there you can also use cellular automata to model the spread of different disease strains in different parts of the world. Another very simple algorithm has to do with what we call grammar. So grammars are usually used to produce more complex structures based on simple ones. So for instance, you can have a building. So here you start with the letter B. B and A in this case are just symbols, and you have production rules. So when you start your production with B, the next production would be A, and then continuing with A, the next production will be AB, and so on. So of course, it's not interesting if it's just letters, but take out the letters and add walls and windows. So A is a wall and B is a window. So you can create quickly something that looks like a house based on this. You can also use it to create, this is the example, images of snowflakes or images of weapons which have a repetitive manner. You can also use it to create plants. Plants, if you observe them, are repetitive in nature in the sense that they have the middle branch, and then they have different branches stemming from this, and then the leaves at the end, and so on. So, of course, you can hire a talented artist and give them $3,000 per month and have them buy a PC that costs another $3,000 and so on, and model each tree. You can do that if you want to be perfect and you want your models to respect nature, then you would go that way. But the other downside with this approach has to do with the fact that these are pieces of code which are very simple. So writing a code that goes like this, you can actually run this code even, I don't know, on a smartwatch, on a computer that is 20 years old. Okay, you cannot have 100 trees on your smartwatch, an environment with 100 trees. You cannot have an environment with 100 trees on a 10-year-old computer, but you can generate it using this code. So this is a major advantage of procedural content generation. You don't have to keep anything in memory. You don't have to take into account all those polygons needed to store trees and buildings and cars and I don't know what else. You can generate them in real time. And the final example uses one of the relatively modern neural network algorithms called LSTM. LSTM stands for long short-term memory. And the difference between this and traditional neural networks has to do with the input that we give to them. So in LSTMs, we don't just give single values or single features as input, we use sequences of features. So if I want to recognize this movement, for instance, I can use the sequence of the positions of my hand as input to the LSTM, and it makes it that much easier to recognize this gesture. So in terms of generation, we would have to encode each level as a sequence of different elements. So in Super Mario, this is where that screenshot comes from. The different elements are listed at the bottom of the slide. We have the different kinds of bricks. We have the empty bricks, of course. we have the enemies, and so on. And the trick that we do here is try to encode the whole level. So we need to have a sequence, as I said, so we cannot give them a two-dimensional structure like this one. So we go this like a snake, moving up and down, and gradually moving from left to right in order to do all this encoding. So I mentioned that each Super Mario level is between 200 and 500 tiles in width, and you multiply it with the different options and so on. This used to be a problem, I don't know, 10 or 15 years ago, when we didn't have network computing or cloud computing. We didn't have much memory on our PCs. We didn't have NVIDIA cards with dedicated hardware and so on. But this is now not so much of a problem. So you can build huge neural networks and run them on either your PC or on a cloud service like Google Colab or Microsoft Azure or AWS or anything. So it's very easy actually to encode this information, encode the level, the definition of a level as a series of different objects and try to generate it. Another modern algorithm is called reinforcement learning. This is actually a visual representation of what we do. So in reinforcement learning, there's no training process in the sense that you can feed it with tons of data and lots of data and so on. You may see examples of reinforcement learning, for instance, on YouTube, with agents learning to park virtual cars. So in the beginning, what we do is go with random directions. And at every step of the algorithm, we calculate a measurable metric of whether we're that closer to our objective or not. So if we're closer, if one particular action brings us closer to our objective, then we'll go down that path. And eventually you would see that these agents learn how to park, they learn how to steer around the virtual track and so on. After 10, 100, 1,000 repetitions, they learn how to play the game without being told about strategies, without being told about rules, just by trying and failing again. So you could have a student completing, I don't know, random answers to your tests, and eventually after 1,000 tries, they would get it right and graduate. Of course, we don't have that luxury as humans, but computers can do that. So the problem with reinforcement learning is that even though it's easy to understand for us humans, okay, if you do an action and this action is good for you, then keep doing that. Okay, it makes sense. In many computer games, it's not very easy to tell whether a particular set of actions actually guides you towards a positive ending. For instance, in chess, you may perform a specific action and you may capture one of the pieces of your opponent, which is nice. But then this specific action, 5 or 10 movements later, may cost you the game. So you will know the actual cost of that action way later in the game. This is why DeepMind did not use reinforcement learning to train their computers to play chess. So it's not very easy, and even though it is generalizable, it's not suitable for all games to actually deploy. But for simple games with a small variety of actions, going back from left, right, or jumping, for instance, like Super Mario, it's very easy to train such an algorithm. So finally, in the concept of generating actual content and environments for the games, this is the result that was submitted in the Minecraft competition, Minecraft Generative Design competition. So you can see the link to the website here and also an introductory video that you can go through. So the idea here would be to, as I say, to write an algorithm that creates a settlement without knowing the topology and the geography of the Minecraft map that you're going to be presented with. So you're given the map, your algorithm is given the map, and it should generate the different buildings, it should generate the different plants or plantations to work with, the different streets and roads and so on. And the means of evaluating the different submissions have to do with the validity and the rationale used in order to create those automatically generated settlements. So, for instance, in your village, in your settlement, you should use materials existing in the environment. So if your state is, I don't know, positioned in the desert, it wouldn't make sense to create houses built from wood, because there wouldn't be any wood to work with. Okay, so your algorithm should respect the actual resources found in the environment. Another interesting thing has to do with the placement of the different buildings. So this is actually an interesting placement, which of course does not make sense, because this algorithm placed the houses right on the water. Okay, so in order to place the house, you would find a suitable position that's kind of flat. Okay, that's of course not in the water, and so on. And another objective has to do with finding good parts or good points at the stage to grow some food, to grow some crops for your villagers, and so on. And these parts should be near clean water. So it wouldn't make sense to start cultivating something next to the sea. Of course, it's easy again to discuss these rules as humans with sentences, but you have to create code for this, and this code has to respect, as I said, the topography and geography of this map. But it's a very nice competition. I would say that in general, the generative design in Minecraft community is a very welcoming community. Initially, the competition would use only Java for generation, because it was the only language supported by Minecraft. But I think these days there are wrappers for all major development programming languages like C# or whatever anyone wants to use. I think even Python. You can also use Python for this. And even though it's a competition, it's actually a good opportunity for young students to interact with more experienced developers. And you can do this also through a very active Discord server that they have set up. So it gives you the opportunity to, as I said, to interact with people working in the academia or working in the industry. As I showed earlier, there is a growing number of actual commercial games which use AI to generate content. So starting from Minecraft, you could eventually move to a larger company like Sony or EA and utilize your knowledge and your ideas for PCG in there. Finally, I would call this as product placement. I would like to invite you to download and read a couple of my recent papers related to how we can use concepts stemming from ancient Greek wisdom, mostly related to the teachings of Plato, Aristotle, and Socrates, to help us actually navigate through the landscape of AI ethics. Now that I said this, both navigate and landscape are words usually used by ChatGPT. So this is actually one of the means that we use to identify essays written by ChatGPT. And I've added it here because your generation, the students who are now finishing their studies and will become the developers of the next generation AI systems, would have to actually tackle a lot of interesting and important problems related to AI ethics. There were many questions in my previous presentations related to safety and security and ethics, and how ethical it is to collect data from users and so on. Of course, there should be quite a few restrictions with respect to that, but of course, we cannot enforce them. Even the European Union, the Data Act that was presented a few weeks ago, it's a set of guidelines, but it cannot be considered as legislation. So given that we as users hand out our information, hand out our data to Facebook, to Twitter, to WhatsApp, to TikTok, to whatever, we need to make sure that we understand how these algorithms work. And this has to do with the initiative that runs within IEEE, which is called XAI, Explainable AI Committee, and we are trying to come up with It's not going to be a standard, of course, because again, it's not going to be enforced. We cannot really enforce or monitor it. But I think we're going to produce a set of guidelines to help us through the different options that we need to make. And at the end of the day, next generation artificial intelligence systems should include ethics by design and not going retroactively back to solve any problems related to ethics, to data leaks, to information being used for malicious reasons, and so on. So thank you very much for your interest and for being here.
Thank you, Dr. Kostas. Anyone has a question? Our guest.
Dr. Kostas, it was a really, really nice presentation. I think I got a lot of ideas how to apply those things. So in terms of fixed networks as well, it's like a transfer learning from one field to another. So my question is that regarding the security and privacy. So there are some of the actual machine learning techniques that can help us in order to preserve the privacy of users, such as federated learning or split learning, right? Because we're not actually sending our data anywhere, but we're doing learning on the actual device and then always sending the parameters. So what do you think are some other maybe techniques that probably you've heard of, because you are the expert in this field, along with federated learning and split learning that can actually help us with the security and privacy of learning?
Yes, that's very interesting. Actually, before you even go to AI, you could do what we call anonymization or pseudonymization. So at the end of the day, Supercell is not interested whether I, as a player, do this, this, and that. They want to train their systems and adapt, for instance, the cost of their heroes and cards and so on. So it makes the difference if it's me or you and so on. So they could remove the identifying information, or they may change this into a numerical value used just to correlate between different actions made by the same player. So this is part of the ethics by design process that I said. They have no interest and they have no reason to know that I, as Kostas Karpuzis, am playing this game and I spent €5 to buy this card and so on. They just want to know that one player did this while on the road or while waiting at the airport and so on. So this is very important, pseudonymization or anonymization. And this actually is, I think, a strategy that should be observed by all people collecting information, even going outside the field of data. If you want to create a questionnaire, for instance, to, I don't know, food delivery companies typically ask you to review your order, right? Whether the food you order was the one that you actually wanted, blah, blah, blah. There is no reason for them to know that you were the one who submitted this information, okay? We shouldn't even ask them to anonymize the data. They have no reason, as I said, to collect your identifying information. So we should begin from that. And then, as you said, you can use other technologies on top of the protected data, such as federated learning or even blockchain. And so on. Blockchain is actually very popular for the gaming companies because it eliminates some of the risks related to cheating. For instance, I can create additional code to run and increase the gold coins that I have in my account by, I don't know, 1 million. Okay, so if my information is stored on a blockchain, that it's nearly impossible for me to attack it. And blockchain is also very relevant if we want to share information with other services. So I can, I don't know, get points from ordering food and then spend those points on my favorite game and so on. No chance of escaping, right? So these modern technologies, one wouldn't think that they are related to games, but again, since everyone is playing games these days, actually currently the game development industry is larger than the entertainment and the music industry combined. So this gives us a sense of how important games are in terms of generated content.
So with the advancements in hardware, games are becoming more expensive to make. And we're seeing that it's harder to break into the market, and plus games are being made, especially AAA games, since these games can take 5, 7, 9 years in development and can cost hundreds of millions of dollars. Studios are less willing to fund risky projects and more innovative ideas. They just don't go with what they know works. And so it causes like less just so within the gaming community, we're seeing less new ideas. With the implementation of AI, which will of course lead to many humans getting let go, do you think this could cause more automation and make games overall in the future have less soul and make us see less new innovative ideas?
So this would make sense, but we haven't seen it happening yet. We have seen some creative jobs being threatened, but they're mostly related to freelancers. So there's a very popular website in the States called Fiverr, where you can ask for someone to do a small chore or a small work for you. For instance, design the logo for your store or for your, I don't know, dissertation or something like that. And you see the decline of requests there and decline of money spent there because people can experiment with ChatGPT, they can experiment with Microsoft Copilot, DALL-E, or you name it. Okay, but this content is not mature enough to be used in the context of games. So game development companies actually continue to hire skillful actors, skillful artists and designers to create the visual imagery or the music for the games and so on. Maybe they can be assisted. Of course, they can be assisted by generative AI. I mean, even Photoshop these days has some tools related to generative AI to fix parts of your image or to expand your image and so on. But I wouldn't see artists being replaced by Gen AI, mostly because Gen AI is trained with human input. So, you know, the creative part is something to be discussed in the context of Gen AI. This also holds for coding. We hear different predictions about coding being a profession of the past, for instance, and so on. But this is not currently happening because the code that is produced by ChatGPT and other agents is not production ready, at least today. Maybe tomorrow, next year, or the year after that, it's going to be different. But again, I would see that someone who knows how to take advantage of these tools, and they can actually, it's not just take advantage, it's just, you need to adapt the things that you do as a software developer. So it's not just writing code, because as you said, the machine can do it for you, and then you can come back and review it and correct it and so on. So the nature of the coding job would change, okay? And of course, if you read something written by ChatGPT, if you see an image generated by DALL-E, you instantly recognize it. So our brains are, I would say, finely tuned to recognize artificial content as opposed to human-generated content. And we still prefer human-generated content. This is actually the reason why massively online courses, MOOCs, okay, online universities, weren't as successful as they were supposed to be, because we still value the face-to-face interaction between students and lecturers. And this became actually evident, painfully evident during the pandemic, because we were all restricted to Zoom. So Zoom-based lectures, of course, are not as fun, and of course, they're not as efficient as face-to-face lectures. So I wouldn't see in the next few years being, overrun by generative AI.
How about,
famous last words.
how about the first part of this question? Is it becoming more and more difficult for newcomers, innovative ideas, small teams to get bigger business?
I think the difficult part has to do with reaching out to the players, because all these companies they spend huge amounts of money with influencers, with sponsors, with paying money to football players to advertise their games on, blah blah blah. It's very difficult not to make something creative and original, but to show it to people. But there have been exceptions to this rule. So by using word of mouth, or using your social networks, or using influencers in your network who will do it in exchange, I don't know for what. You don't have to pay them $5,000, of course, because you don't have that kind of money. Then you may generate the initial traction. So there's a small part of the industry, what we call indie games, independent games. It's like indie movies. Okay, they're made by small teams with a small budget or zero budget, and so on. So my suggestion would be to start with a competition. We call them game jams. They're like hackathons. They typically last 24 or 48 hours, and you can create a game. And then many people who also participate in this game jam will see the results of your work. And surely enough, there are also commercial people watching and monitoring these game jams, and they will see the outcome of your work, and they will not hesitate to contact you. For instance, there's a game jam called Global Game Jam. It happens every January, I think, late January, and it attracts thousands of submissions. Okay, so there are people who monitor these submissions for new talent, young talent, and attract them. Now, I will speak again about the ethical part. So the game development industry is not famous for respecting the work ethics, the work hours of people, the balance between work and life, and we can discuss this, of course, for hours. So it's a mildly toxic environment to work in. But if it makes you happy in terms of creating something, then I would say go for it. Okay.
Thank you very much for this good lecture. I want to ask, what is the secret? How can we find a secret for a game to succeed? We find many games on the net. Our children are trying for them. They don't have a story. They don't have anything intelligent. Even the colors, even the functionalities. This game is not any good from our point of view, because we are all here and we are not seeing the game as our children are seeing them. This is one point. Another point, I think there is an ethical part. How to make our children not paying money for useless things on those games. Our children are trying to make just skills or maths or something, and they are paying a lot of money on that. And I am seeing some problems with some families from this point of view. And this child is trying to pay every other day a new skin, a new weapon. And as we know, from the technical part, from the technology part, that's not, and he's paying money for nothing. If he's paying the money to buy a game, it's okay. But to buy a skin, to buy a glass that this hero is wearing a new glass, there's a problem with that.
Yeah.
Is there any ethical part related to that?
So regarding your first question about the secret to creating successful games, apologies for this, but if I knew the secret, I wouldn't share it with anyone. Okay? It's not about the technology. It's not about the franchise, FIFA, EA, or something. It's not about the interface. Maybe simple ideas are easier to understand. My usual example for this is Angry Birds. Angry Birds has the simplest graphics in the world, like It's like a 5-year-old drew the different heroes. The simplest mechanics, you just do this, okay? But it was a free-to-play game that generated more than 100 million euros for a number of years. So people would pay money, as you said, for nothing. Okay, so now for the ethical part, this is usually a question that we deal with respect to casino games, to card games, to betting, and so on. So the concept of responsible gaming is at the moment constrained to these sectors because they're followed and observed by the different gambling commissions that need to oversee these companies. I think in terms of spending, our only solution or salvation would be to add some kinds of limits on our device. So I think that Google supports this, Google Pay. So you can restrict it to spend, I don't know, 10 euro per month or 100 euro per month, or you can add different means of authentication. So even if a child took my phone, they wouldn't unlock that specific feature because it would require my fingerprint and so on. And as we discussed earlier, what constitutes zero value is different to us than to other generations. For instance, my daughters, they listen to K-pop, Korean pop, like BTS or something like that. And there was a time when they spent their pocket money to buy small pictures of their favorite singers, which would make sense in our generations. We used to collect small panini stickers of footballers and so on. But these days, they have all these pictures on their mobile phones. They don't need to have them in print form. But again, who am I to judge? Okay, so as long as it is controlled, then it's okay. And this is, I think, the point that we as parents need to step up and inform our children about what it is that they're doing and enforce some sort of limits.
Thank you very much. First of all, regarding AI, extended AI, I think as the computer state members, we are receiving invitation for webinars. I think every now and then, I think the next one maybe on the 27th. I'm not sure, but I'm thinking for everyone to attend these webinars, online webinars, useful for us. Something else regarding, I think yesterday we have a discussion about the possibility of using large language models. Or maybe more than one large models to have benchmark. For example, we can produce games. For example, today you talk about procedural content generation (PCG). Maybe we can use two large language models to have production, and we can compare between these two large language models in this task. Or maybe we can play games, mainly text-based games, and we can see the performance. Of course, this could be somehow subjective because maybe the content you like, I don't like, so that maybe you have more than one grader for the content. But what about the possibility of using games as a task with different large language models to judge the performance? Thank you.
So large language models are a very good fit to generate text. So they can create the narrative, they can create the dialogue, and so on. That's the easy part. What I would do would be to take into account the whole context of the game when feeding it as input to ChatGPT or whatever, Gemini or whatever. For instance, you have a game about cowboys in the Wild West, okay? And I'm entering the saloon. So the context of this interaction is that this character enters the saloon, his name is this and that. So the bartender corresponds with one particular generation of dialogue. That's one thing. Maybe after I play, I fight with someone and I get injured, or I come into the saloon holding a gun. Okay, this is more important and more useful contextual information. So the bartender has no visual input, but they know the context. So their dialogue would be instead of what do you want to drink, how come you're injured, or please put that gun away because you're scaring the other customers, and so on, which makes the whole discussion more realistic, so to speak, and it gives the whole concept of adapting and corresponding to what happens in the game. So I, as a player, realize that my actions have impact on what's happening in the game, and it's not that the NPC is a robot that will greet me every time they see me, even though they saw me, I don't know, 5 minutes ago. So I would add as input all the contextual information, because when you ask ChatGPT for information, you don't just say, write an essay about this and this and that, you try to guide it. This is what we call prompt engineering. So I would add all the information available to the bartender in this case for this, and of course the history, because if we have interacted using text before, this can also be used with ChatGPT. Now ChatGPT can remember thousands and thousands of tokens of different words, so it can remember pretty much everything that happens within a game session. So I would use it to create meaningful dialogue that makes sense and can be compared to humans discussing with each other. There was a video released a couple of days ago by OpenAI advertising the new version of ChatGPT, and it actually shows a user holding their mobile phone like this and using the speech. They're using speech to enter different prompts, and they get almost in real time the responses in less than, I think, 300 milliseconds. So we can exploit this, we can take advantage of this for our non-player characters.
Thank you. I think with this we conclude our talk. I'd like to thank you, Dr. Kostas, for being with us today. Now it's time for the food game. It's on the other side of the lobby in the